this module, you will learn about the streamline flow and the equation of continuity for fluids. The study of a fluid in motion is defined as fluid dynamics. For example, consider water flowing from a tap. The water column from the tap is smooth as the water begins to flow out. As the water descends from the tap, its speed increases and it eventually loses the smoothness of the flow. To understand why the smoothness of the flow of the tap water changes, we need to understand the fluid's motion at the particle level. The path taken by a fluid particle in its flow is called its line of flow. The direction of motion of the particle is given by the tangent at that particular point on the line of flow. Fluids can flow steadily or turbulently. The flow of a fluid is said to be steady or laminar if all the particles passing a given point maintain a steady velocity at that point. The velocity of a given particle may vary from one position to another in its path, but at a given point in the path, all the particles passing through the point have the same velocity. Each particle follows the same path taken by a previous particle passing through that point. The path taken by a fluid particle in a steady flow is called a streamline. The motion of the entire fluid can be represented with a number of streamlines showing the direction of flow in different areas. Thus, steady flow is a streamline flow. As the tangent at a point in the streamline indicates the direction of motion of all the particles at that point, no two streamlines cross each other. Consider an area in a fluid in a steady flow. All the streamlines that are drawn from the periphery of the area constitute a tube for which the chosen area is the cross-section. Such a tube is called the tube of flow. As the streamlines do not intersect, fluids flowing through different tubes of flow do not intermix even though there is no physical partition between them. Fluid dynamics can be better understood taking into consideration the following three factors studied along with the concept of tube flow. They are incompressibility of liquids, rotational aspect of fluids, and viscosity. Liquids are largely considered incompressible when compared to gases, as they don't change volume in response to pressure as gases do. When the fluid flow is along a straight line, it is called irrotational, whereas when the fluid swirls, the fluid is called rotational. The viscosity of a fluid is related to the internal friction when a layer of fluid slips over another layer. In a non-viscous liquid, the effect of friction is neglected. We have learnt earlier that a fluid flowing through a tube of flow does not intermix with the fluid in other tubes. This implies that the total mass of the fluid entering a given tube through any cross-section of the tube in a given time interval is equal to the total mass of the fluid flowing out of the tube from any other cross-section in the same time interval. Consider a tube of flow represented by AB with area of cross-section A1 and A2 at the two ends A and B. Let V1 and V2 be the velocities of the fluid at ends A and B. Consider an incompressible, irrotational, and non-viscous fluid flowing in a streamline flow in the tube. To find the volume of the fluid, VA going into the tube with the velocity V1 through the cross-section A in time delta t. Consider a small cylinder of length V1 delta t. The volume of the fluid going into the tube through the cross-section at A is A1 V1 delta T. If ρ is the density of the fluid, the mass of the fluid, MA, entering the tube at A in time delta T, is A1 V1 delta T ρ. Similarly, consider a small cylinder of length V2 delta T at the end B. Then, the volume of the fluid VB going out of the tube through the cross-section at B in the same time delta T is A2 V2 delta T. Hence, the mass of the fluid, MB, leaving the tube at B in the same time delta T is A2 V2 delta T ρ. As the fluid is incompressible, its density remains constant. As the mass of the fluid entering is equal to the mass of the fluid leaving the tube, we have A1 V1 delta T ρ is equal to A2 V2 delta T ρ. On simplification, we get A1 V1 is equal to A2 V2. This expression is called the equation of continuity. If we consider various points in the tube where the velocities of a fluid are different, we can write A1 V1 is equal to A2 V2 is equal to A3 V3, and so on, equal to AN Vn. Thus, we can say AV is constant. The equation of continuity is valid as the product of area of cross-section and speed remain the same at all points of a tube of flow. The equation of continuity represents the conservation of mass in the case of moving fluids. So far, we have considered the laminar flow of fluids. In practical or real-time situations, the flow of fluids is not always laminar. The velocity of a particle at a point in a fluid varies with time. In such a case, the flow of the fluid is called turbulent flow. If the velocity of a particle in a fluid crosses a particular value, called critical velocity, the flow changes from laminar to turbulent. Critical velocity is the velocity of a liquid at which its flow changes from laminar to turbulent. The speed or the direction of the flow varies in turbulent flow. Thus, the motion of water in a waterfall or a fast-flowing river is turbulent. In the case of water flowing out of a tap, the velocity of water increases as it descends. Thus, at a particular point, the velocity of the water crosses its critical velocity and the flow of water changes from laminar to turbulent. You've now reached the end of this module. In this module, you learned that the path taken by a particle in a flowing fluid is called its line of flow. The direction of motion of the particle is given by the tangent at that particular point of the particle. The flow of the fluid is said to be steady or laminar if all the particles passing a given point maintain a steady velocity at that point. The path taken by a fluid particle in a steady flow is called a streamline. Fluids flowing through different tubes of flow do not intermix. The equation of continuity is valid as the product of area of cross-section and its speed remains the same at all points of a tube of flow. The equation of continuity represents the conservation of mass in the case of moving fluids. In a turbulent flow, the velocity of a particle at a point in a fluid varies with time. Critical velocity is the velocity of a liquid at which its flow changes from laminar to turbulent.